Welcome. In this session, we'll learn how to do simple math computations in Matlab and how we declare variables in Matlab. Let's start. Let's open Matlab. This is Matlab. In Matlab, we type the commands in command window. Let's begin with the operations like addition, subtraction, multiplications, and division. Let's do 2 plus 3 is 5. 5 plus 8 is 13. 100 plus 300 is 400. 30 minus 20 is 10. 23 minus 9 is 14. 17 minus 9 is 8. 4 multiplied by 5 is 20. 9 multiplied by 3 is 27. 10 divided by 2 is 5. 15 divided by 5 is 3. 100 divided by 20 is 5. This is how we do addition, subtraction, multiplication, and division in Matlab. Now suppose we have to compute the remainder of this division operation. Matlab has an inbuilt function to perform this operation. It is to compute the remainder of the division operation. Matlab has an inbuilt function, and the function is rem. Now what we do, we write rem, and inside the small braces we type the arguments. Now what are the arguments? Suppose we want to compute the remainder of 23 divided by 5. So we write 23 comma 5. So this will give us the remainder of this 23 divided by 5. That's 3. Similarly, we can type remainder of 17 comma 5. That's 2. Matlab also has another inbuilt function to do the same operation, to compute the remainder of the division operation. And that function is modulo function. And we write MOD in short for this. For example, 17 comma 3. So this will give me the remainder of 17 divided by 3. So that's 2. Another example for this is 29 by 3. So this should give me 2. So this is how we compute the remainder of any division operation. Now before I proceed, I want to clear the screen. To clear this screen, just type CLC. This will clear the screen. Now next, what I want to do, I want to compute a number raised power to any number. Suppose we want to compute 2 to the power of 3. So I write 2, this cap notation, and 3. So this will compute 2 to the power of 3. Similarly, I will do 3 to the power of 2 is 9. 16 to the power of 2 is 256, and so on. Matlab has an inbuilt function to compute the same. And the function is POWER, power. And if I do 16, means 16 to the power 2 will give me 256. Power 3 comma 2 is 9. Power 3 comma 3 is 27. Means 3 to the power of 3 is 27. This is how you compute the power in Matlab. Means a number raised power by any number. Next is if we have to compute the log of any number. Now log we can have of any base. Suppose we want to compute the natural log of any number. To compute the natural log in Matlab, we type log, and inside the small braces we type the number. Natural log of 10 is 2.3026 up to 4 places of decimal. Natural log of 1 is 0. Natural log of 100 is 4.6052. Now I want to compute the log of any other base. Suppose I want to compute the log out to the base 10. To compute log to the base 10 of any number, we type log 10, means log to the base 10, and the number we type inside the small braces. Log to the base 10 of 100 is 2. Log of base 10 of 10 is 1. Log of base 10 of 1 is 0. Log of base 10 of 23 is 1.3617. This is how we compute log of base 10. Similarly, we can compute log of base 2 of 4. Similarly, I can compute log of base 2 of 8. Log of base 2 of 64. This is how we compute log of base of any base in Matlab. Next, I want to compute exponent of any number. Exponent means e to the power of any number. And Matlab has an inbuilt function to do this. I type exp of 1, exp of minus 1. This will compute the exponential of e raised to power minus 1. I can type exponent of 10. That's this number. Exponent of minus 5 is e to the power of minus 5. Similarly, if I have to compute square root of any number, to compute the square root, I can do it by using the power function. There's 2. Suppose I want to compute the square root of 2. That's 2 to the power of 1 by 2. So this is square root of 2. I can do square root of 3. I can type 3 to the power of 1 by 2. This is square root of 3. Now Matlab also has an inbuilt function to compute the square root. That's sqrt. And inside the braces we type the number for which we want to compute the square root. Square root of 100 is 10. Now if I have to compute the cube root, I can use this function. Means the power function to compute the cube root. I can type, suppose I want to compute the cube root of 2. I type 2 to the power of 1 by 3. That's same as cube root of 2. So this is cube root of 2. Matlab also has an inbuilt function to compute root of any order, and that's called nth root. Nth root, and inside the small braces we type 2 comma 3, means cube root of 2. This is cube root of 2. Nth root of 27. Suppose cube root of 27 is 3. But if I want to compute cube root of 1000, so this is 10. This is how we compute root of any order in Matlab by using the nth root function. Now before I proceed, let me clear the screen. Type CLC, this will clear the screen. Next, if I have to execute any algebraic expression, means to evaluate any algebraic expression, let's suppose we take an example 5 divided by 7 multiplied by 7. Now following the BODMAS rule, this should give me the result equal to 5. So this is 5. Similarly, I can do 2 plus 3 to the power 2. Now following the BODMAS rule, this should give me 11, because 3 to the power of 2 is 9, 9 plus 2 is 11. Similarly, I can do 6 plus 5 multiplied by 2. That's 22. So this is how we do execute algebraic expressions in Matlab. I want to clear the screen. Now, how do I enter pi in Matlab? Now, in Matlab, we write pi for pi. So this will give me the value of pi in Matlab. And we know Matlab, pi after 4 places of decimal is 3.1416. So this is pi in Matlab. Next, I want to compute the sine of any angle in degrees and in radians as well. Now suppose I want to compute sine of pi by 2. Now sine pi by 2 we know is equal to 1. Sine of pi by 6, that's sine 30 also. So sine 30 is 1 by 2. Now these values are in radians. These values are in radians. If I want to enter the values in degrees, I type sine d. This informs Matlab the value that I will type is in degrees. Now sine 30 is 1 by 2. Sine 90 is 1. Similarly, sine d is sine of 0 degree is 0. I can type cos 0 is 1. Cos of 60 degrees is 0.5. Cos of 90 degree is 0. This is how we write values in degree and radians in Matlab. Now before I proceed, I'll clear the screen. Type CLC, this will clear the screen. Next, how do I write imaginary numbers in Matlab? Now to write the imaginary numbers, Matlab uses two letters. One is I, another is J. Matlab understands both I as well as J as complex numbers. If you type I, this will give you the result 0 plus 1I. So this is an imaginary number. Similarly, if I type J, this will give me 0 plus 1I. So Matlab understands both I and J as imaginary numbers. So I can type 2 plus 3I. So this number has a real part equal to 2 and imaginary part equal to 3. Similarly, I can type 5J. This number has real part equal to 0 and imaginary part equal to 5. Now I can do the computations on these imaginary numbers. I can do 2 plus 3I plus 5 plus 2J. So 2 plus 2 is 7, 3 plus 2 is 5. That's how we do computations on imaginary numbers. Similarly, if I type cos d of 90 plus j sine of 90. Now cos 90 degree is 0, sine 90 is 1, so this should give me plus 1j or 0 plus 1i. Now if I type exp means e to the power of pi by 2 multiplied by I, that is e to the power of pi by 2 multiplied by I. Now this gives the same result as cos 90 plus j sine 90. Because we know this is Euler's identity, and according to Euler's identity, this will be cos pi by 2 plus I sine pi by 2. And cos pi by 2 is 0, sine pi by 2 is 1. Similarly, I can type exp of minus pi by 2 times j. So this will be minus j. As we know, j and I are identical for Matlab. They are imaginary numbers. So this is how we do computations on imaginary numbers in Matlab. And before I proceed, let me clear the screen. Type CLC, this will clear the screen. Next, I want to declare variables in Matlab. To declare variables in Matlab, we write the variable name on the left-hand side and then type equal sign and assign the value that we want to assign to this variable on the right-hand side. Suppose we want to declare a variable that's x is equal to 2. So I type x is equal to 2, variable name on the left-hand side and the value that I want to assign to this variable on the right-hand side. This will assign 2 to this x. You can check it from the workspace window. Similarly, I want to put y equal to 3. So this assigns 3 to the variable y. Similarly, I want to do z is equal to x plus y. So z is x plus y, x is 2, y is 3, so 5, so y, z is 5. Similarly, I can do m is equal to x to the power of 2. X is 2, this is 2 plus 2, 2 plus 2 is 4, so m is 4. Similarly, I can do a e to the power of x. X is 2, this is e to the power of 2. e to the power of 2 is 7.3891. So this is how we declare variables in Matlab. Next, what I want to do, I want to clear all my variables in the workspace. So I type clear all. So this will clear all the variables in my workspace. Now if I want to clear the screen as well, I type CLC. This will clear the screen. But suppose I created some variables in the current session and I want to use these variables when I come back to use the Matlab later in the later session. Suppose x is 2, y is 3. So this is, I created these variables in my current session and I want to use these variables when I come back to use this Matlab in the later session. So to save these variables for the later session, what I can do, I can type save, enter, and this will save my variables x and y on a Matlab file that's called matlab.mat. Now I can clear these variables and type CLC. All the variables in Matlab memory are cleared. But if I want to retrieve the variables back, I can type LOAD load. This will load my variables x and y. So x is 2, y is 3. So this is how we declare variables and how we can save these variables for later session in Matlab. Next, I want to do one example. If I type 2 plus 3, now 2 plus 3 is 5. Now Matlab automatically assigns the value of this expression to a special variable that's ANS. And the value of this expression is assigned to this variable ANS, and that's equal to 5. That you can check from the workspace window. Now Matlab arranges these variables in the workspace window by alphabetical order. If you type A is equal to 6, 5, you can see the Matlab arranges these variables in the workspace window in alphabetical order. So first thing, if you do not assign the value of the expression to any variable in Matlab, Matlab will assign a special variable to this expression and store the value in workspace. For example, I do 3 multiplied by 5. Now Matlab assigns this value of this expression to a variable, special variable, and assigns the values to it in workspace that you can check from here. So this is how we declare variables in Matlab. Now let me clear the screen. Type CLC, this will clear the screen. Now if I type x is equal to 2, I'm able to see the value in what's stored in x on the next line. But if I do not want to see this result in the next line, I type x is equal to 2 and type semicolon. This will suppress the result. Now Matlab will not show it, display the result. Similarly, I can type x equal to 5 and suppress the result. Now the value of x is changed to 5, but it didn't show the value on the command window. So it's your choice whether you want to display the result on the in command window or not. You can do that by just typing the variable, then the value on the right hand side, and if you want to display the result, you can do it. You don't need to type the semicolon. If you want to suppress the result, type the semicolon. See, S is declared in the workspace, but it didn't show the value of the variable in command window. So if you want to see the value of this S in command window, type S. This will display the result. So this is how we declare variables in Matlab. Next, before I end this session, let's do let's evaluate an expression in terms of these variables. Suppose we have recorded a temperature of a room in Fahrenheit, degree Fahrenheit. Now I want to convert this Fahrenheit value to degree centigrade value. Now suppose the temperature recorded is 50 degree in Fahrenheit, and I want to convert this in degree centigrade. I know the conversion formula between Fahrenheit and degree centigrade temperatures. C is the temperature in degrees centigrade, and that's equal to in Fahrenheit. F minus 32 means temperature in Fahrenheit minus 32 multiplied by 5 divided by 9. Now C is the temperature in degrees centigrade. I can check the value. So this is the temperature in degrees centigrade. Similarly, I can type F is 100. And if I type C, you can see it didn't update the value of C. Why it didn't update the value of C? Because I haven't executed this expression yet. So to execute this expression, what I have to do, I have to type it again. Now, if I want to simply execute this expression one more time, what I can do, I can use my up arrow key on the keyboard and go back to this expression. So using up arrow key thrice and then pressing enter, this will update the value of C. Now you can check the value of C is updated in the workspace. And if you want to see this value on the command window, you can type C and this will display the result. So this is how we declare variables in Matlab. In the next session, we'll discuss how we declare arrays in Matlab. That's very, very important topic. All right, let's stop here.